Hey everyone, welcome to RGB Web Tech, where we simplify tech for you. In this video, we will talk about what is machine learning. Machine learning is a branch of artificial intelligence that focuses on creating systems that can learn from data and improve their performance over time without being explicitly programmed. Instead of following fixed instructions, machine learning models identify patterns in large amounts of information and use those patterns to make predictions, classify data, or make decisions. At the core of ML is the idea that computers can learn from experience, similar to how humans learn. For example, if you show a machine learning model thousands of photos of cats and dogs, it can learn to distinguish between them based on patterns it recognizes. Machine learning is commonly divided into three types. 1. Supervised learning. The model learns from labeled data, e.g. emails marked as spam or not spam. 2. Unsupervised learning. The model finds hidden patterns in unlabeled data, e.g. grouping customers by behavior. 3. Reinforcement learning. The model learns through trial and error by receiving rewards or penalties, e.g. training robots or game-playing AI. ML powers many everyday technologies, such as recommendation systems, voice assistance, fraud detection, medical image analysis, and self-driving vehicles. It is a fundamental driver of modern AI advancements. Why machine learning matters? Machine learning matters because it plays a central role in transforming data into meaningful, actionable insights, powering many of the technologies we rely on today. Its importance comes from several key factors. 1. Unlocks the value of big data. Modern life generates massive amounts of data. ML can analyze this information quickly and accurately, revealing patterns and trends that would be impossible for humans to detect manually. 2. Improves decision-making. Organizations use ML to make smarter, data-driven decisions, whether predicting customer behavior, detecting fraud, or optimizing business operations. This leads to better outcomes and greater efficiency. 3. Drives automation. ML enables systems to automate complex tasks, from email filtering to supply chain optimization. This reduces repetitive work, lowers costs, and increases productivity. 4. Enhances personalization. ML powers personalized recommendations on platforms like streaming services, online stores, and social media. By learning user preferences, it creates more engaging and relevant experiences. 5. Fuels innovation in key industries. ML is revolutionizing fields such as healthcare, finance, transportation, and education. It supports early disease detection, improves risk assessment, powers autonomous vehicles, and enables adaptive learning tools. 6. Enables adaptive and self-improving systems. Unlike traditional software, ML systems improve over time as they process more data, making them increasingly accurate and effective. 7. Supports problem-solving at scale. ML helps tackle global challenges like climate modeling, energy efficiency, disaster prediction, and scientific research. In short, machine learning matters because it strengthens decision-making, increases efficiency, and drives innovation, making it a foundational technology shaping the future. How machine learning works. Machine learning works by enabling computers to learn from data, identify patterns, and make predictions or decisions without being explicitly programmed. Although ML methods vary, most systems follow a similar process. 1. Data collection. ML starts with data, images, text, numbers, audio, or any information relevant to the problem. The quality and quantity of data strongly influence how well the model will perform. 2. Data preparation. The collected data is cleaned, organized, and formatted. This may include removing errors, handling missing values, and normalizing inputs to ensure the model can learn effectively. 3. Choosing a model. Different ML algorithms are suited for different tasks. A. Supervised learning for prediction and classification. B. Unsupervised learning for pattern discovery. C. Reinforcement. Learning for trial and error decision-making. Training the model. The model is fed data so it can identify patterns. A. In supervised learning, it learns from labeled examples, e.g. cat versus dog. B. In unsupervised learning, it groups or organizes data without labels. C. In reinforcement learning, it learns through rewards and penalties. During training, the model adjusts internal parameters to reduce errors. 5. Testing and evaluation. The model is tested on new, unseen data to measure accuracy and performance. Metrics like precision, recall, or error rates help determine how well it is learned. 6. Deployment. Once validated, the trained model is integrated into real-world systems, like recommendation engines, fraud detectors, or medical image analyzers. 7. Continuous improvement. Many ML systems continue learning over time, updating themselves with new data to stay accurate and relevant. In essence, ML works by combining data, mathematical models, and computation to mimic aspects of human learning, allowing machines to make smarter, more informed decisions. Types of machine learning. Machine learning can be categorized into several key types based on how a model learns from data. The three main types are supervised learning, unsupervised learning, and reinforcement learning, with additional subcategories used in advanced applications. Here's a clear breakdown. 1. Supervised learning. Supervised learning uses labeled data, meaning each input comes with a correct output. The model learns to map inputs to outputs and generalizes this knowledge to new data. Common uses: A. Email spam detection. B. Predicting house prices. C. Image classification. Types of supervised tasks: A. Classification, predicting categories, e.g. dog versus cat. B. Regression, predicting continuous values, e.g. temperature, prices. 2. Unsupervised learning. Unsupervised learning uses unlabeled data. The model explores the structure of the data to find patterns or relationships on its own. Common uses: A. Customer segmentation. B. Anomaly detection. C. Market basket analysis. Main techniques: A. Clustering, grouping similar items. B. Dimensionality reduction, simplifying complex data. 3. Reinforcement learning. Reinforcement learning teaches an agent to make decisions through trial and error. The agent interacts with an environment, receives rewards or penalties, and learns an optimal strategy over time. Common uses: A. Robotics. B. Game-playing AI, e.g. chess, Go. C. Self-driving cars. 4. Semi-supervised learning. A mix of supervised and unsupervised learning, using a small amount of labeled data and a large amount of unlabeled data. Use cases: A. Fraud detection. B. Speech recognition. 5. Deep learning. A subset of ML that uses neural networks with many layers to learn complex patterns. Use cases: A. Image and voice recognition. B. Natural language processing. C. Autonomous systems. In summary, the main types of ML, supervised, unsupervised, and reinforcement learning, form the foundation of modern AI systems, with advanced techniques expanding their capabilities even further. Advantages of machine learning. Machine learning offers powerful advantages that make it one of the most impactful technologies in today's digital world. Here are the key benefits. 1. Automates decision-making. ML systems can analyze data and make decisions automatically, reducing the need for human intervention in tasks like fraud detection, quality control, or recommendation systems. 2. Handles large volumes of data. ML is highly effective at processing and analyzing massive data sets, far beyond what humans can handle, while identifying patterns quickly and accurately. 3. Improves over time. Unlike traditional software, ML models learn and improve as they're exposed to more data. This leads to better predictions, higher accuracy, and continuous performance enhancement. 4. Delivers high accuracy. ML can outperform humans in tasks like image recognition, medical diagnostics, and anomaly detection due to its ability to uncover hidden patterns. 5. Enhances personalization. From streaming platforms to online shopping, ML tailors content and product recommendations based on user behavior, improving experience and engagement. 6. Boosts efficiency and productivity. By automating repetitive tasks and optimizing processes, ML helps organizations reduce errors, save time, and increase operational efficiency. 7. Enables predictive analytics. ML predicts future outcomes, such as market trends, equipment failures, or customer needs, helping businesses plan proactively. 8. Supports innovation. ML drives breakthroughs in robotics, healthcare, autonomous vehicles, finance, cybersecurity, and many other fields. Overall, machine learning provides smart automation, deeper insights, and ongoing improvement, making it a foundational tool for modern technology and business innovation. Disadvantages of machine learning, ML. Machine learning, ML, has powerful capabilities, but it also comes with notable disadvantages that organizations and individuals must consider. Here are the key drawbacks. 1. Requires large amounts of data. ML systems need extensive, high-quality data to perform well. Collecting, cleaning, and labeling this data can be time-consuming and expensive. 2. High computational and financial costs. Training ML models, especially deep learning models, requires significant computing power, specialized hardware, and ongoing maintenance. This can be costly for smaller businesses. 3. Risk of bias. If the training data contains biases, the ML model will replicate and amplify those biases. This can lead to unfair decisions in areas like hiring, lending, or law enforcement. 4. Lack of transparency. Many ML models, particularly neural networks, function as black boxes. It can be difficult to understand how they make decisions, which raises concerns about accountability. 5. Overfitting and underfitting models may perform well on training data, but poorly on new data, overfitting, or they may be too simple to learn meaningful patterns, underfitting. Both lead to unreliable results. 6. Security vulnerabilities. ML systems can be manipulated through adversarial attacks, small intentional data changes that mislead the model into making incorrect predictions. 7. Dependency on skilled experts. Developing, tuning, and deploying ML models requires expertise in data science, programming, and mathematics. Skilled professionals can be costly and difficult to find. 8. Ethical and privacy concerns. ML often relies on personal or sensitive data, raising concerns about privacy breaches, surveillance, and misuse of information. While ML offers tremendous benefits, these disadvantages highlight the need for responsible development, proper data governance, and continuous oversight. Future of machine learning. The future of machine learning is poised to bring transformative changes across industries, technology, and everyday life. As ML continues to evolve, several major trends and advancements are expected to shape its future. 1. More advanced and efficient algorithms. ML models will become faster, more accurate, and more efficient. New architectures, like advanced neural networks and optimized learning techniques, will reduce the need for massive datasets and expensive hardware. 2. Growth of explainable AI. As ML systems become more integrated into critical decisions, healthcare, finance, law, transparency will be essential. Explainable AI will help users understand why a model made a decision, improving trust and accountability. 3. Integration with everyday technology. ML will become even more embedded in daily tools, smartphones, home devices, cars, and wearables, leading to highly personalized and adaptive experiences. 4. Major advances in healthcare. ML will support earlier disease detection, personalized medicine, automated diagnostics, and drug discovery. Healthcare ML models will become more accurate and widely adopted. 5. Autonomous systems expansion. Self-driving cars, delivery drones, and intelligent robots will rely heavily on ML to navigate and learn from their environments more safely and effectively. 6. Edge machine learning models will run directly on devices, edge computing, instead of relying on cloud servers. This means A. Faster processing, B. Better privacy, C. Less dependence on the internet. 7. Increased focus on ethical and fair. ML governments and organizations will enforce stricter regulations to prevent bias, protect privacy, and ensure fair use of ML technologies. 8. ML augmenting human abilities. Rather than replacing humans entirely, ML will serve as a powerful assistant, helping doctors, engineers, teachers, scientists, and creators make better decisions and work more efficiently. 9. Continuous learning models. Future ML systems will learn in real time, adjusting to new data instantly instead of requiring full retraining. The future of machine learning will bring smarter, more transparent, and more integrated systems that enhance human life, accelerate innovation, and reshape industries, while raising important questions about ethics, privacy, and responsible use. If you found this video helpful, hit that like button, leave a comment with your question, and do not forget to subscribe for more tech tutorials. Thanks for watching, and I will see you in the next video. Goodbye, and take care.